So today we are going to learn to graph the reciprocal trig functions. We're going to learn to graph the reciprocal trig functions. So cosecant, secant, cotangent. Now remember that cosecant is just 1 over sine. So if we know how to graph sine and we use what we learned this morning on how to graph reciprocal functions, we will be able to create the graph for cosecant. So we start, remember step 1, the first major thing was draw the original graph. And then we're going to complete the steps for drawing the reciprocals, which means that we'll do our asymptotes and some values that we know, and then the y value gets changed to 1 over y, and see what happens. So here's our first one. The graph of sine is already given. You know that the period of sine is 2 pi. It starts at the middle, goes to your max, back to the middle, down to a min, back to the middle, and so on. So if that's our graph of sine of x, and we want to graph the reciprocal, we would start with asymptotes. We draw vertical asymptotes when there's an x-intercept. So there are a lot of them. There's one here. Ooh. I'm going to do one here. Yeah. Use your infinite cloner on your own paper. Here we go. There's another one there, 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 and another one there. How many vertical asymptotes in total will cosecant have? Infinite. So if we labeled them all, this one is x equals negative 4 pi, x equals negative 3 pi, x equals negative 2 pi, x equals negative pi, x equals 0, x equals pi, x equals 2 pi, x equals 3 pi, and x equals 4 pi. Wow, almost. So Dryden, how would I write all the asymptotes equations? The equations of all the asymptotes, x. And here we would use the equal sign because we're making an equation of an asymptote. We're not looking at domain. So we'd say x equals, and just like you said, k pi, where k is an integer. Will there be an asymptote at y equals 0, a horizontal asymptote? No. There's only a horizontal asymptote if your graph goes up forever or down forever. So the next thing we're going to do is points. Now, we talked about it earlier. Key points are maximums and minimums. What is the value at this maximum? 1. And what's going to happen to that when you do the reciprocal? It stays the same. So all of our values that are maximums stay the same. What about our minimums? The value at our minimum is negative 1. It stays the same. Just for fun, can someone tell me another point on the sine graph, the original sine graph? And when does that happen? Can you tell me? Here's point 5. What are the coordinates of that point? No. Something comma 1/2. What's the something going to be? It won't be pi over 4. Pi over 6. Because what is sine of pi over 6 from your pi plate? 1/2. So we have pi over 6 comma 1/2. And what's going to happen to that point when you do 1 over the y value? You're going to get pi over 6 comma 2. And what is this section of our graph going to look like? like this, and this one over here like this, and this one over here like this. And the bottom, there was, yeah, on one of the very first, and I had to say, oh, you don't have to do that yet. So there is our graph of cosecant. We could do the domain and range of our blue graph. What's the domain? Well, the domain is everything except x can't equal k pi, where k is an integer. What is our range? Y is less than or equal to -1, and we write the word or. Y is bigger than or equal to 1. That would be our range. Yes?
Yeah, okay, so how are pi plates going to work for the exam?
How are pi plates going to work for the exam? They will work as follows. You will get a formula sheet. Oh, the formula sheet doesn't help you. And on the back of the formula sheet, which you tear out, has extra information about how to explain and what different words mean. And then there's going to be another tear out sheet on your exam that has a blank unit circle.
So like the little ones that we got for the trig test?
So, oh, this one's been ripped out. So here is last year's exam, June 2016. It tells you when you open it up. By the way, I hope you like purple because this will be the color of your exam.
Yay! I just like that purple.
So let's graph secant. What do we do first when graphing reciprocal?
We have to switch.
Asymptotes.
You're wrong. We're supposed to draw sine.
So now we're doing secant. We are going to yeah, cos is already pre-drawn here for us. Draw all of our asymptotes wherever we have x-intercepts. And label them. And we notice that wherever we have asymptotes are the same place where we had zeros.
So do we have to write them all out, or do like for all the ones we have on the page, or do we just?
Usually they'll ask you only for like from -2 pi to 2 pi. So this is more than.
And then do we have to do the general as well?
Well, we'll write out the general and just to practice, because this is reviewing, right? If we want to write the equation of all the asymptotes or the domain, that practices our zeros for cos that we did before. What are all the equations? Ooh, that's a G. They'll all be x equals. Do you remember how to write the odd numbers? We did it in two different ways. One way we wrote it was 2k plus 1 pi over 2, where k is an integer. The other way that we wrote it is starting with one of them. So start with pi over 2. And then what distance is it from another one? Cut plus k pi, where k is an integer. So those are two ways that you can write your equation of your asymptotes for secant. They're the same as the two ways that we wrote our zeros for cos. Is there going to be a horizontal asymptote at 0?
No, it's not going down.
That's right. All of these points stay the same. Can someone tell me what this point is? Something comma 1/2. Pi over 3. From your pi plate, cos of pi over 3 is 1/2. So when we do the reciprocal of that, we're going to get 2. And we get the same looking graph. It's just translated over. Just like cos is the same looking graph as sine, just translated over. Well, you don't. So, I mean, this one, we would call it a cos graph because cos graph starts at a maximum. But we could write an equation for this graph as a sine graph moved pi over 2 to the left. And so both would be right. There's more than one right equation for this graph that we have here. There's going to be questions on your exam that say find an equation, and they might be specific and say find a sine equation or find a cos equation for the following graph. But if they're not specific, you could choose whichever one you wanted. But usually they are specific, so make sure you read the question carefully. And the final one is a little bit awkward. Okay. It's a little bit awkward because of the horizontal asymptote. The vertical asymptotes are exactly as you would think, exactly where tan is equal to 0, we now have new asymptotes. Whoops. Whoops. I was going to try and do it shorter, but it's not working, so I'll just draw them all in. Now, an interesting thing about the cotangent graph is even though cotangent is 1 over tan, and we're going to use the tan graph to help us, by definition, cotangent is also what over what? It's also cos over sine. So wherever sine is equal to 0, that's a non-permissible value. And that's why we get all of these asymptotes at -4 pi, -3 pi, -2 pi, -pi, and so on. But what's interesting is, here, I'll just write them all in. The asymptotes for tan, because what is the other way to write tan? Sine over cos. The asymptotes for tan happen when cos is equal to 0. Right? Okay? But if we use this definition for cotangent, can you see that cos could equal 0? And when cos is equal to 0, what's cotangent? 0. And this is where the graph of cotangent doesn't quite follow all the rules. Notice your tangent graph goes up forever and down forever, right? So normally, we would have an asymptote at y equals 0. But in this case, because if we think of cotangent as cos over sine, what happens when cos is 0? Cotangent is 0. So instead of having asymptotes, all of these points are actually equal to 0. Can someone tell me the coordinates of this point? Pi over 4, comma 1, right? Can you tell that that point's going to stay the same? In fact, wherever it's equal to 1, it's going to stay the same. And wherever it's equal to negative 1, it's going to stay the same. One more. Now, having the tan graph and the cotangent one on the same one with all of these asymptotes makes this very busy. Sorry about that. But the cotangent graph, if you think about the red asymptotes are the asymptotes of cotangent. We now have 2 green points and a black point for cotangent. Here's our cotangent graph. Woo! I was getting nervous there. I was like so impressed that I went through the points so quickly and so nicely in the first ones. I got a little bit nervous with this one. And yeah, it went a little wonky. Put our arrowheads on. Yeah, lose a half point for shape of graph. But there is the cotangent graph. And at the bottom, if you would like, you can characterize domain and range. Again, what's the domain of cotangent? X can't equal k pi. What's the range? Everything. What are the equations of the asymptotes? X equals k pi. What other characteristics are there? Y-intercepts and zeros. Well, we can find our zeros wherever cos is equal to 0. So that's pi over 2 plus k pi. Do we have a y-intercept? Not in this case because there's an asymptote. So we could characterize everything for this one.